Hey guys, so there was a question on, um, there was a few questions on the packet regarding the last problem. So, this is number 3 from the packet that we did in class. So again, we're looking at the conservation of momentum. So the momentum before any collision, so any momentum before is going to equal any momentum after. Okay, so what we do here is we're looking at this specific collision, and we're trying to determine what collision it is. So this collision is an inelastic collision. So what occurs here is one ball is moving towards the other. At the end, they have collided and they're going in the same direction. So M1, so if it's inelastic, we M1 V1 so the momentum of ball A is equal to the momentum of ball B. So 1 is equal to A, 2 is equal to B. So I'm just assigning these numbers to, so this number correlates with ball A, this number correlates with ball B. So once they've collided, all the momentum before the collision is going to equal all the momentum after the collision. So this is the collision occurred here. Now their masses are combined. So they've combined, and they're going to be going at the same velocity. So mass 1 plus mass 2, so the mass of ball A plus the mass of ball B are going to exit at the same velocity. So we'll use the signal that they use, so V prime. So in this case, we have the mass of 1, which is 2 kilograms, times its velocity, which is 5 meters per second, plus the mass of ball B, which is 3.5 kilograms, times its velocity, which is 0, is going to equal the mass of ball 1, so the mass of ball A, so 2 plus 3.5. Now these two are in kilograms, and I didn't write that, so I should have. And then I'm just solving for V prime. So in this case, I have 10 plus 0 is equal to 5.5 times V prime. So I have, in order to solve for this, I have 10 divided by 5.5. It's going to give me my velocity. And that is going to equal 1.81 meters per second. Good. Okay. Now, problem number 2. So problem C in this case. Now, this is a typo. We can ignore it. It is an inelastic collision, so it's the same as the one above. Now we're just trying to determine the mass of ball A. Okay. So if we have a collision, again, it's inelastic, so same formula that we use. M1V1 plus M2V2 is equal to the masses of them combined. And we have that V prime. So we know this velocity, we know this velocity, and we know this velocity. We're looking for this mass here. Okay, so we can do that just, again, plugging in each number. So same thing, it's in an inelastic collision. So the mass of 1, we're considering that ball A. The mass of 1 we do not know, so M1 is unknown. V1 is 6 meters per second, plus this is at rest, so it would be 0, the momentum would be 0. We don't know M1 plus M2, and that is 1 kilogram, times 4.8 meters per second. Okay, so in this case, again, we're still solving for M1. So 4.8 M1 plus 4.8 is equal to 6 M1. So in this case, subtract 4.8 M1, subtract 4.8 M1, and that gives me 1.2 M1. 1.2 M1 is equal to 4.8. So divide by 1.2, and this is going to, so M1 is equal to 4 kilograms. Okay, if you guys have any other questions, go ahead and email me. I will be, I have a few more screencasts to post up, so be patient. They will be up shortly. All right, thank you.